The problem is given two numbers x comma m, we have to find out the power of x raised to the m. So you can see that we are given the numbers, just a minute. we are given these two numbers x and m, and we have to find out x raised to the power m. So basically we can do this by the naive method or naive solution, and in this we have to multiply the x with another x each time. So here this is first time, this is second time, till m times we have to multiply this x with another x. So then we can get x raised to the power m. In doing so, we are iterating through m steps, and this will be the code look like, and the overall time complexity of this code will be order of n. And we want to find out an algorithm which can reduce this time complexity to less than this order of n. Let's look at it. So efficient method. The main logic behind the efficient method is, look at the example 3 raised to the power 9. It can be written as 3 cross 3 raised to the power 8, and this 8 can be written further written as 3 times 3 raised to the power 4 whole square, and this can be further written as 3 square whole square whole square. So if you observe that we are having 1, 2, 3, 4. In total we are having 4 multiplications. But if we are doing in the naive procedure, we have to multiply this 3 with other 3's 9 times. So here we are having 9 steps, and here we are having only 4 steps. Suppose consider the number 2 to the power 8. In the naive procedure we have to follow 8 steps, but here it can be done as 2 square whole square whole square. So 1, 2, 3. We are having only 3 steps to go. So you can observe that if you follow some procedure that can do the multiplication in this way, then the time complexity will be reduced to order of n to order of log n. So we can obtain the optimized solution. So you can observe that if the power is 9, we have to write the multiplication as 3 raised to the power m minus 1 into 3, so that this can be even. Now as this is even, we can write down it as 3 raised to the power m by 2 when m is even. So 3 raised to the power 4 whole square, and again this is even, so we can write 3 square whole square whole square. So you can look at the logic of this optimized solution as, if the here n is nothing but the power, x is the base and n is the power. If the power is even, then we can write down it as power of x to the power n by 2 whole square. So this is only just a single step. We can reduce this one, as we have already found out from this. It will be reduced by 2 steps. At each step we will be doing like this, and the overall time complexity will be order of log n to the base 2. And if at all the power is not a even, it's a odd, then we can simply break down it as x into x to the power m minus 1, so that this will be even, and in the further steps we can easily follow this first step to divide it by 2 each time. So this is the basic idea behind the optimized solution of the power. Now let's look at the code. So you can clearly observe that we are given the numbers x and n, and we have to find out x raised to the power n. Let's implement this code using the example 3 raised to the power 5. 3 raised to the power 5, power of 3 comma 5. So here x is 3 and this n is 5. Now you can observe that this n is not equal to 0, so we will come to here, and this temp is equal to power of x comma n by 2. So now we are dividing it by 2. Later we will check whether it is odd or even. First let's divide this by 2 so that we can get 5 by 2 as 2. The divisor will be 2, and we have recursively called the power of 3 comma 2 here. This is another recursive call, and you can observe that again we have entered this function, and here n is not equal to 0. So again we will come to this step, and again we will divide this 2 by 2. So we will get 1 as the new n value. So we will call a function with x as 3 and n as 1. So again we will divide this by 2, and we will call the function again recursively with 0 as the value of n. Now you can observe that we have reached the base case. That is, if n is equal to 0, then we can return 1. So that this will return 1. This will return 1 to the function power of 3 comma 1. And you can observe that as this is the odd number, we have to return temp cross x. As we have obtained the temp as 1 cross 3, we will be returning, and this will return 3 to this. Now you can observe that we are at this step. Just we have called power of 3 comma 2, and we have obtained the result as 3. And you can observe that 2 by 2, this is here n is 2, and this is the even thing, and we can directly return temp, which is temp cross temp. So we can return 3 cross 3 to this power of 3 comma 5. So again we have reached this step. We are in the first recursive, we are in the first case, we are in this recursive call, and you can observe that here n is 5, which is odd. So we will return the result as, basically first we will make this temp as temp cross temp. So 3 into 3 whole square into, as this is an odd number, we have to multiply with x 3. So you can obtain the result as 3 power 5, we can get the result. So if you observe that just we are making log 5 to the base 2 calls. We are not making 5 calls which we are doing in the naive processor. So this is a optimized solution. But you may observe that there is a problem here. Even though the time complexity is order of log n, the auxiliary space complexity is also order of log n, because we are using the array of we are using the stacks for these function calls, and auxiliarily we are using order of log n space. So this can be reduced by using the iterative approach. This is the recursive approach, and by using the iterative we can reduce this time complexity, space complexity. So I will make another video on that. You can look at that. Thank you.